times E 0.15 is 0.15 times 7. You see, my calculator is a mess. So, and then E to that, and then times 300. It's going to be 857.3. We round to we give a round number because this is like bacteria population. So it's very hard to say to put a decimal number for the population, right? We agree with me? Okay, when we say what is the population after 1 day, how much? What number we plug in? Do you plug in 1?
24.
We plug in 24. We have to pay attention here. The number you have to plug in this model has to have same time unit. It has to have same time unit that is in the problem right here. We say after T hours, you see, we only plug in hours. When we say what was the population after 1 day, we plug in 24. What was the population after 60 minutes, after 45 minutes, we plug in what? After 45 minutes, what number we plug in?
0.75.
0.75. Thank you very much. We convert 45 minutes into hours. Is 0.75 hours, right? Etc. etc. This is one question we can ask about this type of problems. The other question we can ask is B is to say how long it will take for the population to reach 10,000. All right. So now, what are we asked to find? The N or the T?
The N.
The N is a function, is the population, right? Do we know the population? Do we know the population? Was this question B? Do you know how much? Do we know how much is the population? Do you know it or not?
The population is 10,000.
It's 10,000, right? But we don't know how long it's going to take for the population to reach that, right? So we don't know the time. We don't know T, but we know N of T, right? You see here, in my model here, in the question A, I was given the T. I'm asked how to find the N of T, right? That's what we did. In the question B, I am given the N of T, which is 10,000. See, that is N of T. It's 10,000, and I don't know the T. How much is the T, right? So what I'm going to do, in my model here, I say 10,000 equal to 300 E 0.15 T, right? And then I solve for T. You see that? You only is going to see these two type of questions. If you have to have this stuff, you're going to see only these two type of questions. When we give you the independent variable and we ask you to find the dependent variable N of T, that is easy, just plug in the number. Or we give you the dependent variable, which is N of T, and we ask you to find the independent variable, which is T, right? Now, I'll let you like a couple of seconds to solve this one now. Everybody know how to solve this equation? It was on the test, right? A lot of people did solve them right. So what we do first to solve this equation? What we do first?
Divide by 300?
Exactly. We divide by 300 because we want to have the exponential term free. So we divide by 300. So this one is going to be E 0.15t is equal to 10 over 100 over 3, right? Now, what is next? What is the next step?
Convert it to exponential?
It is exponential already. Convert it to
Logarithmic.
logarithmic, right? And can you tell me what's going to be the log form of this equation? What is the log form of this equation?
Ln 100 over 3.
Yes, equal to
0.15.
yes.
T.
T, exactly. And then at the very end, we divide by 0.15. So we say T equal to Ln of 100 over 3 divided by 0.15. So Ln 100 over 3, and then we put the Ln, and then we divide that by 0.15. So we get 23 hours, 23.4 hours. All right. This is the type of application problems in the exponential topic that you can expect to have. But like I said, the only two questions we're going to ask you about this, because of the level of math we are doing, is either we give you the time and we ask you to find the population, or vice versa. We give you the population, we ask you to find the time. The second question is longer, is harder than the first question, right? Okay, but that's going to be anything that is exponential growth. We also have the exponential decay, right? We also have the exponential decay, which is when the function is decreasing, right? Right? A good example of exponential decay is, for instance, the radioactivity. The radioactivity is a very, very good example of the exponential decay, right? It is because of the radioactivity, radiations. When you have a mass, a radioactive mass, after a certain time, that mass will diminish, right? Okay, after a certain time. For instance, you see, we have this is like M. You have M grams, which is the initial mass of a radioactive material. After some time, this M grams becomes the half of it. Basically, it loses the half of the mass. The half of the mass is lost, right? Okay, in this topic, do you know in physics how we call the time that elapsed? That time has a name. Do you know the name? In physics? Let's say you originally you have 20 grams. After a while, you lose, because of the radiations, you lose 10 grams. Now you have 10 grams left. After a while, you get 5 grams left, etc. Do you know what is the time that has elapsed here? How we call it in physics? Somebody knows?
The half-life.
Thank you very much. Half-life. Right? After another while, after another half-life, this one is also divided by 2. You see, it's going to be m over 2 over 2, which is m over 2 squared, right? After another half-life, it becomes m over 2 cubed, right? etc., etc. After another half-life, it becomes m over 2 to the fourth, and so on, right? After each half-life, the mass is divided by 2 after each half-life, okay? So that is a good example. That is a good example of an exponential decay. It's something that is decreasing exponentially, right? It is decreasing exponentially, all right? So now, in general here, we say, since it's very hard to observe what is a half-life, so the exponential base 2 here, you see, so basically we get m of t is equal to m0, which is initial mass, E negative, I mean, not E, it's 2 to the negative 2 over h. The h is a half-life. You see here, you have one half-life, h. This is 2 to the 1 power. So, and here we have two half-lives, is 2 squared, right? Etc., etc. So, but since it is very hard to find what is a half-life of something, okay? So the general model, this model is very restrictive because this model uses a half-life, but it's not like obvious to get what is the half-life of something. You have to observe. If you are in a laboratory, right, you are exactly looking when this stuff will be divided into, you are exactly tracking that time. It can take you a long time to get it, right? But what is the exponential decay problem model is m of t, the general model is m of t is equal to m0, which is the initial mass or something, E negative RT. So exactly like the exponential growth, except now we have a negative sign here that make it decrease. It's going to decrease this way, right? So M0 is the initial mass, okay? And R is relative rate of decay. And M of t is a mass after time t. Okay? So exponential growth, exponential decay, these are some type of applications. Now, if I go, let me look at the review, and then I'm gonna pick one problem from the review, I think, that is about this stuff, this topic right here. Review, okay, right here. That is a review for the final exam. Let me go to the problem that is about that. Okay, right here. All right, so can you hear me now?
Yeah.
I was talking with myself for a while. I even didn't realize, you know, teams sucks in that regard. Okay, it really does. So it just, you know, throw you off and you even don't realize it. Okay, so I was saying right here, we say this one right here is, it's given. A of t is called the mass that is left after t years, right? The mass that is left after t years. How much mass will be left after 100 years? What we do, simply what we do was this question. How much mass will be left after 100 years?
You substitute 100 for t.
Exactly. As long as the units, the time units match, if the time units match, then you substitute. It's just 8. This question is only what is a of 100. We give you a of t, a function, and we ask you what is a of 100. The answer is very simple. This is a of 100, which is equal to 34 e negative 0.00244 times 100. That's it. And then you use a calculator to find the answer. It's 0.00244 times 100, right? And then minus that equals this, say e to that, and then times 34. So after 100 years, we have 26.7 left. 0.6 grams, right? Left. How long, you see, we ask pretty much, we ask the same questions. How long will it take until 20 grams remain? What you do? Now the 20 gram will represent the left side or the right side?
The left
20
side.
grams represent the, in here, 20 grams will be the A or the T?
A.
The A, 20 grams here is A of T. So we're going to be 20 is equal to 34 E negative 0.00244 T. And we're going to solve for T, right? Okay. So go ahead. How are you going to solve for T? What should we do first?
Divide by 34.
Thank you very much. You divide by 34, right?
Yeah.
Divide by 34. So we get 20 over 34, right? So we get E negative 0.00244 T is equal to 20 over 34, which is 10 over 17, right? And then what is the next step? What is the log form of this stuff?
Negative 0.00.
Equal to what?
ln of 10 over 17.
Exactly. ln of 10 over 17 equal to negative 0.00244 T, right? So we get T equal to ln of 10 over 17 all over negative 0.00244, right? If I take my calculator out, I got 10 over 17 equal ln of that, which is this, and then divided by 0.00244 negative. So 217 years. Okay. All right. Just in case, you know, we never know, in the final exam, if you have this type of problem. These are the two questions we're going to ask you. The first question is a very easy one. We give you just a number to plug in. The second question, you will have to solve some type of problem, right? Okay. So this basically pretty much closes, you know, our topics, you know, of course, for 163. If you have a few time left, you can go ahead and, you know, try to, like I said, the review, you can go ahead and review all these right here. You know, you have a lot of problems. So by the way, you don't have to focus on the number 21. Number 21, don't pay no mind for number 21. I will not ask you about for the review. Everybody sees the review here? Everybody sees the review, right? I will not ask you about, I will not ask you about this on the final exam, right? So I will not ask you about this on the final exam, right? I will not ask you about this on the final exam, okay? Yeah. You know, just to, you know, I will not ask you about that. But for everything else, you can have, I think it's fair to say you can have it on the final exam. So if you want to review, for instance, the first stuff we learned, how to solve the equations here. You see, we can also look at the test we did at the same time. You see, right here, solving quadratic equation. Everybody knows how to solve, you know, quadratic formula. This equation right here, number 3, you can see it's a similar one in the review where you can see the similar one. Right here, B, right? You see, x to the 4th plus 7x squared minus 8 equals 0. Or this one in our test 1 is the same thing, right? They solve exactly the same way. So, but let's take the one in the review, official review, right? Answered. All right, back then, do you remember what we did? We said, back then we said, for instance, W equal to x squared, right? Or U, or however we called it. When you do that, then my equation becomes W squared plus 7W minus 8 equals 0, right? And this equation happens to be factorable. It's W minus 1 times W plus 8 equals 0. So we get W equal 1 or W equal negative 8. So are we done solving? Are we done solving this?
No.
We're not. W is what? X squared. So x squared equal 1 or x squared equal negative 8. So we get x equal to plus or minus 1 or x equal to plus or minus I square root of 8. Okay, so for the review, you have the review and you have the review key, right? So we have the review and you have the review key. You have the key for the review. So, but you're going to see that. And then if you look at here, we have an absolute value equation, right? Absolute value equation. So absolute value equation. So remember what you do. Before we break it down into a couple of equations, we need to have the absolute value by itself, right? So we're going to subtract 3, so we get 3x minus 6 equal to 27, right? Now, do you remember what we used to do? We used to break it down into two equations, 3x minus 6 equal 27, or 3x minus 6 equal negative 27, right? And then we solve. So we get x equal to 33 over 3, which is 11, or x equal to negative 21 over 3, which is negative 7, right? You remember that? Okay, if you always focus on the absolute values, look at 2A, 2B. Before we go to other material, we focus on the absolute values right here. So this one right here. Okay, this is an absolute value inequality which has greater than or equal to. So first we subtract 1. We get absolute value of 4x minus 9 is greater than or equal to 11. Okay, now comes the main step. Do you remember how we used to break it down, this one?
Negative 11 greater or equal to 4x.
Minus 9, yes.
Yeah.
And then, or thank you very much. Yes, you have to separate, right?
Yeah.
4x minus 9 greater than
11.
11. Thank you. This is how we used to break it down, okay? The greater than or equal to, you cannot break it down this way. You cannot do negative 11, this, 4x minus 9. You cannot do that. This is wrong, okay? You have to separate. So now we add 9, so we get negative 2 greater than or equal to 4x. We divide by 4, we get negative 1/2 greater than or equal to x, or x is greater than or equal to 5, right? So basically my solution will be, I have negative 1/2, I have 5 here. It's going to be the outside, the outer intervals, right? The two outer intervals. Okay? The two outer intervals. So this is a greater than or equal to case. The other case is when we solve the less than or equal to case. That's the other one. Which is this one right here. Okay, so here, how are we gonna, what you have to do first? We have to get rid of the 5, right? We get negative 3x plus 1 is greater than negative 3. And then when you multiply by negative sign on both sides, right, to get the absolute value by itself, what's going to happen? You're going to change the greater than to less than, right? Okay. Everybody understands these steps right here? Do you have a question about this test? I mean, this step right here? All right. So now, do you remember how we used to break it down now that we have the absolute value by itself? Do you remember how we used to break it down? Do you remember how we used to break it down? We say what? Negative 3 less than 3x plus 1 less than positive 3, right? Okay?
Yes.
That is the easiest way to remember that. That is the easiest way to break it down. There is no or here. It's and. Okay? So it's going to be minus 1, minus 1, minus 1. We get negative 4 less than 3x less than 2. And then we divide by 3, we get negative 4 third less than x less than 2 third. So basically, the less than or equal to case is going to be always the inner interval, right? It's going to be the one in the middle. I mean, this is open now because we don't have equal. By the way, you have to show the work, In test number 3, I see people, who don't show work for some questions, you have to show your work. Okay? You have to show the work if you want to get the points. If you don't show the work, pretty much. So this is how it goes. You have two cases. You know how you get the answer. If you know how to get the answer, just put it in writing. Okay? And you get the points. If you don't know how to get the answer, that is exactly the problem. So why you put why somebody would put a right answer and they don't show, it's not nice. It's not like, what the teacher going to think is they took it from somewhere else. This is what I think, you see. If I see the right answer with no work, absolutely no work, my thing is you took it from somewhere. That's cheating, you see. Because if you know how to get the answer, just write it down. If your answer comes from A plus B plus C, write A plus B plus C. I don't see why somebody would not write it down. I don't understand. Unless if somebody used something, if you use a calculator or you use a computer or use something else, you got the right answer, but you don't know how you got the right answer. You see, so it does not show the students in the bright light, okay? Please, for the final exam, if you know where your answer comes from, write it down. At least write down a few steps until I understand where you got your answer from. If you don't write it down, in my head, you are cheating. You got the answer from somewhere else. I just cannot prove it, but you got the answer from somewhere else. It's as simple as that. So, I ask you a question, even myself, I need to do steps to get the right answer. Even myself. I do math for a living, right? So I have to do steps to get the answer. So how come somebody can get the right answer with no steps? Where does this answer come from? I always see that in the test. I always see it in the test. And you have to write down your answers. I mean, your steps. All right. So, okay, now let's see what else, these right here, they were in the test number 3, right? This problem right here. Log of x plus 2 minus 3 equal 1. Let's try to do some of them. Log of x plus 2 minus 3 equal 1. Of course, we just did it last week. Of course, you have to get the log by itself, right? So we say 3 plus 3 plus 3. So we get log of x plus 2 equal to 4. Okay, tell me, what is the exponential form of this equation?
X plus 2 equal to 10.
Exactly, 10. 10, because when the base is missing, it's not because we forgot about it, it's because it's 10. 10 to what power?
4.
10 to 4 power. Thank you very much. Everybody see that? Okay, so now we get x equal 10 to the 4th minus 2. Okay? That is a logarithmic equation. So always in this topic right here, if you have the next one here is exponential equation, 6 to 1 minus 2x plus 2. Right? Insert. Six, we did, similar equations, just, in the first hour. So we're gonna get the exponential by itself, right? By doing 6, 1 minus 2x equal to 10, right? By subtracting 2, subtracting 2. Now, what is the log form of this? The easiest log form of this log base what? What is the base? base
6.
6 of what?
10.
Of 10 is equal to 1 minus 2x, right? That is a log form. And then we subtract 1, so we get negative 2x is log base 6 of 10 minus 1, and then we divide by negative 2. Okay? So now, if somebody wants to use a calculator, what we said last time is you can say x equal to ln of 10 divided by ln of 6 minus 1 all over negative 2, right? You can do that also. Okay? So I think this one right here, radical equations, no, I'm gonna pass on this one. So this one right here, how to solve a quadratic equation. Not everybody did that in this class, for the test number 3. Not everybody did that, okay? Actually, a lot of people didn't get it right. So the calculations here are very, very limited, right? We don't have a lot of calculation in it. First of all, what we're trying to do, we're trying to factor, right? If we can, hopefully we can factor this one right here. Okay, so how do you factor this one? See 3x squared minus negative 60, and negative 60 is what numbers you can use? Negative 12 and positive 5, right? Minus 12x plus 5x minus 20. So we get 3x times x minus 4 plus 5 times x minus 4. So you get x minus 4, 3x plus 5, right? That's how you factor this one. So x minus 4 times 3x plus 5. But if I were to give you something like that on the exam, I just will give you something similar to, to one we got on test number 3. Well, that is very easy to factor, not something like that. This one needs the AC method, right? So now what next now? Look, a lot of people got it wrong. What next? The next step is I have my number line. I need this. You see, this is a work. If I don't see this stuff right here, if I see from here somebody say S is negative infinity, negative 5 over 3, union, right? Union 4, infinity. If I see somebody writing this is what exactly what I'm talking about. Where does this answer come from? You see, as a grader, when I grade, I ask myself, where does this answer come from? I see a lot of people jumping from the equation to the answer with no work whatsoever. Where does the answer come from? Now, when you write the answer, if you know where your answer comes from, write it down on paper so I can grade. If you don't know where your answer comes from, then that is a problem then. Everybody understand that? Please write down the work. All right? So, and the work is very simple. I put the zeros. What are the 2 zeros? They are negative 5/3 and 4, right? And then I just test numbers. You see, I test numbers to see when my stuff is positive and my stuff is negative. I just test numbers. There is nothing more, nothing less. For instance, if I test 5 here, 5 minus 4 is positive. 3 times 5 plus 5 is positive, right? Here in between, if I test 0, 0 minus 4 is negative. 3 times 0 plus 5 is positive, is negative. And here, if I test negative 2, I get a positive number, right? So now I'm looking for a positive sign here, plus. That's why I got a plus here. And that's why I got a plus here, right? Okay. After that now, when I write this now I can write the solution. You see, this comes after this, right? So without a number line or whatever, however you can present, some people present a table. I agree with that. Some people present a table like this, they put this, they put x minus 4, they put 3x plus 5, right? Etc. This is like negative 5/3. This is 4. They say this is minus, plus. This is minus, plus, minus. And then they say, okay, this is plus, minus, plus, etc. You see, and then this is the solution. You can present your answer this way. It doesn't matter. You present it this way, or you present it this way. It's the same thing. But I need to see some work. Okay, so please, this is a final exam. Write down something so I can give you credit. If you don't write nothing, I don't give you credit. All right. We're going to do one more, and then we're going to stop here. We're going to dismiss the class today, and then when we come back, we're going to continue the review next year. Okay, so this one, the next one right here. All right, the next one. First of all, I'm going to factor. Again, what is my goal? What I do all the factoring because I need to do this. That is my goal. That's why I do all the factoring. This is x times x plus 5. This is x minus 3, x plus 3, right? So I got my zeros. I have 4 zeros. I have negative 5. I have negative 3. I have 0 and positive 3. Again, I'm going to look what is the sign of the expression in each interval. For instance, here, after 3, I'm going to plug in 4 to see what I get. I get 4 plus 5 over 4 minus 3, 4 plus 3. I see everybody positive, 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 positive. So this is plus. So now I'm kind of lazy. I'm kind of lazy to plug in 4 more numbers, 1, 2, 3, 4. What I'm going to use? I'm going to use the fact everybody is a cross point, right? Everybody is a cross point, so I don't have to plug in. So because everybody is a cross point, the signs will alternate, right? And now my solution is what I see is a negative sign here, right? So I see minus here, right? And the negative 3 and positive 3, they cannot be included because they make the denominator 0. These two included. So I get solution is negative 5, comma, negative 3, union 3, comma, infinity. All right? When you come back Thursday, so we're going to try to go over the review, and see how we're going to do number 3, number 4, etc. right? The review is very comprehensive, right? So remember how to graph a piecewise function, how to graph a polynomial, how to find the zeros, etc. right? Okay, so we're going to dismiss the class today. Please do not forget, again, don't forget to submit your project. Either you're going to submit it on Brightspace or you're going to send it to my email before 11:59 tonight, okay? Please. All right, everybody.
Sir, please.
So hold on a second. So Carlos, don't go anywhere. I need to talk to you, please. Okay, say again. Sherry?
Okay. When is the final exam?
The final exam?
Yeah.
You don't know what is the final exam? It's on the syllabus, right?
Yeah, I went on the syllabus. I just saw test 1, test 2, test 3, and quiz 1, quiz 2.
No, it's all the way down. It's all the way down. It's not where it's all the way down right here.
Comprehensive.
Right here. Everybody sees right here? The final exam is December the 16th from 12 to 2. Not 12:30, not 12:45. Okay, everybody, if you come 12:45, You're gonna miss 45 minutes, okay?
Okay.
It's 12 to 2 p.m. Again,
Okay.
look at the final, look at the syllabus all the way down. It's not like it's all the way down. All right, everybody.
So
So
instead of Zoom, it will be on Team, right?
yeah, yeah, of course. This was done when Zoom was when we were using Zoom. Now it's gonna be on Teams. Yeah.
Okay, thank you.
All right, everybody. See you Thursday, right?